recording first. I've started the recording. So Sandra, welcome. And kama kawaida, you'll start by introducing yourself, introduce your team, and then take us through the session. Karibu.
Okay, thank you, Patrick. So my name is Sandra Wanjira. I'm part of Team Air. So the members for our team, you met part of the team on Tuesday. Yeah, Tuesday. That is frank and fun. And for today's class, we'll be taking you through the rest of the topics. And the members of the team, the other members of the team are Gideon, Musembi, and Silas. So yeah, I guess we can start. Let me just share my screen. Give me a minute. Patrick, I can't share my screen.
Hey, give me a second, just a second. Able try now?
Also, apologies for any noise that might be there. I'm not in the house.
No worries, no
Okay.
worries, no worries. You're good.
Okay. Are you able to see my screen?
Yes, we are.
Okay, so for the morning session, we'll be covering the module on scaling and NIM resolution. And we'll go into the resources or services that AWS provides for you to easily scale your resources. And yeah, so I'll start with the first topic. We'll be covering elastic load balancing. And so for this topic, the content that we'll cover is the importance of scaling. We'll describe this elastic load balancing service. We'll cover the different types of ELBs. And we'll also look at the components of this elastic load balancer. So, scaling overview. Scaling, I think we've covered this quite a lot. We've mentioned it a few times. So, scaling is the ability to increase or decrease compute capacity to meet fluctuating demand. So, you can scale out when demand increases, or you can scale in when capacity needs to be decreased. So, for traditional data centers, you're limited because traditional data centers are limited by fixed hardware capacities. Businesses must buy extra servers for peak periods, and these extra servers during idle period, during the not peak periods, they just sit idle. So that's a limitation for traditional on-frame data centers. However, for cloud compute for in the cloud, computing power can scale up or down as needed. Amazon EC2 autoscaling automatically adjusts the number of servers based on the demand. You can specify pre-made selections such as a maximum, minimum, or capacity threshold in order to help ensure that your solution meets demand while also maintaining your limits. So in the cloud, you can automatically scale through resources such as autoscaling, and you're able to specify what is the maximum number of resources that you might need, what is the minimum number of resources that you might need, and also what is the ideal capacity that you might need. So this enables you to meet the demand and also maintain your limits. This ensures efficiency and cost savings because you also pay only for what you use. Benefits of auto scaling. Number one is fault tolerance. This replaces unhealthy instances and uses multiple availability zones for reliability. Another advantage is high availability. It keeps enough capacity to handle current traffic demand. So I guess we covered this there's a team that covered the difference between fault tolerance and high availability. So availability, you're ensuring all your resources are available. Okay, are available. Okay, you're ensuring that you're meeting the demand. And then in tolerance, you're minimizing the downtime that you can experience. Another advantage of auto scaling is that you're able to get better performance. Auto scaling enables you to add instances during high traffic to maintain fast response times. It also enables cost efficiency because you can scale up or scale down and you only pay for only what you use. So these are the components of auto scaling, and these are what we'll be covering today. So the rest of my team will touch on Amazon Route 53, and I'll be covering elastic load balancing, and Gideon will cover auto scaling. So these are the components for scaling. Um, Components that you need for scaling. You need Amazon Route 53, you need elastic load balancing, and an Amazon EC2 auto scaling group. So yeah, take note of that. These are what you need to auto scale Route 53, ELB, and auto scaling group. Okay, so we'll cover the first resource that you need for auto scaling, which is the elastic load balancing service. So ELB is a highly available service which is responsible for traffic distribution across EC2 instances. ELB does the following. It automatically distributes your incoming traffic across multiple targets, such as EC2 instances, containers, and IP addresses in one or more availability zones. So, what this means is if there's high traffic, say for example, right now, take the websites such as Amazon. Right now, during this season, Black Friday, there are a lot of sales. So a lot of people are heading to that website. And so there's a lot of traffic. So what ELB does, it distributes these requests from clients to different, um, to multiple targets. Could be an EC2 instance, could be a container, could be an IP address. Um, yeah, The ELB also monitors the health of its registered targets and routes traffic to only the healthy targets. It automatically scales your load balancer capacity in response to changes in incoming traffic. So those are the things that ELB does. Once you receive high traffic, it will distribute your requests to the different targets. But before it distributes to the different targets, it first checks whether the target is healthy. If it's healthy, it proceeds on to redirect the traffic there. And it also enables you to increase your capacity or decrease depending on incoming traffic. So here we have the features of ELBs. Number one, we have high availability. Elastic load balancing automatically distributes traffic across multiple targets. So we've mentioned this. It could be an EC2 instance, container, or IP address. And it could also be in a single availability zone or multiple availability zones. ELBs also offer health checks. ELBs can detect unhealthy targets, stop sending traffic to them, and then spread the load across the remaining targets. So we've also said this. Before it sends traffic to a certain target, it first of all checks if it's healthy. If it's not, it either terminates it or stops sending traffic to them, and then it will redistribute to the remaining healthy targets. It also offers security. You can create and manage security groups that are associated with load balancers. You can also create an internal load balancer. The other feature is layer 4 and layer 7 load balancing. In layer 7, this is the application layer in the OSI model. It looks at what the user is asking for, say a web page or image, and decides where to send it. In layer 4, that is the transport layer, it looks at the data's address and sends it to the right place without checking what's inside. And then another feature is TLS termination. ELBs provide integrated certificate management and SSL decryption, allowing you the flexibility to centrally manage the SSL setting of the load balancer and offload CPU intensive work from your application. So earlier we learned that TLS and SSL they help you keep your information safe and secret. So with elastic load balancers, it's already integrated with certificate management and SSL decryption. So it takes away this work from the CPU. And so it does that work for you. And then we have operational monitoring. ELB provides integration with Amazon CloudWatch, metrics, and request tracing in order to monitor performance of your applications in real time. So you're able to integrate ELB with CloudWatch and you're able to monitor your performance. So some of the use cases of ELBs, they can be used to secure access to your web server through a single point of access. It exposes only the load balancer, and it also which acts as a security gate that safely routes traffic while hiding your servers. So this means instead of people request directly getting to your servers, it first of all goes through your load balancer. So the load balancer is the only exposed point. The other use case is to decouple your environment using public load balancers for internet traffic and internal ones for private traffic. Just a minute, guys. I'm sorry for that. Can continue. Um, So yeah, you can decouple your environment. You can either use a public load balancer. This allows you to access traffic from the internet. And you can also have an internal one for private network traffic. A company's website will use the public load balancer for customers and an internal load balancer for employee apps. So you're able to decouple people who can access from the internet and who can access from within. The other point is to provide high availability and fault tolerance with the ability to distribute traffic across multiple availability zones. So we've looked at that. It also increases elasticity and scalability with minimal overhead. So yeah, those are the use cases for ELBs. And in conclusion, the goal of load balancing is to ensure applications are available, performant, and scalable. Okay, any questions up until there? All right. Okay, let me just see the chats. Okay, there. So we look at the different types of load balancers now. So number one, we have a classic load balancer. So this is the original version of AWS load
Sarah,
balancer.
you're not sharing your screen.
Oh, oops. Let me share. And right now, Gideon,
Yeah, we can see it.
Okay, so we'll cover the different types of load balancers. The first one, we have a classic load balancer. This is the original version of AWS load balancers. It was used with the now outdated EC2 Classic platform. So it provides basic load balancing across multiple EC2 instances. How it works: instances are registered directly with load balancers. It operates in layer 4 and layer 7 of the OSI model. Some of the features of this classic load balancers is it supports these protocols. It supports HTTP, HTTPS, TCP, and SSL and TLC traffic. It also provides a single point of access to servers. It offers basic health checks and sticky sessions using application cookies. So when we say sticky sessions and cookies, we say it means that when sticky session is enabled, the cookie acts as a name tag for your session. The load balancer reads it and makes sure all your requests go to the same backend server. So what this means is, take for example a Google form, or maybe you're applying for a job and you're required to fill in your details in that form. So what happens when you enable sticky sessions? The data that you fill is saved in a server, and so when you move to the next page of the form, it's the cookie makes sure that you're redirected to the same server that you are at, so that your data is not lost. Say you filled the first page, personal details, you go to the next section, educational background. It won't redirect you to another server where it doesn't know what you've been doing, it doesn't know what details you'd added on your personal information. So that's what sticky sessions and cookies enable you to do. It's like a name tag for your session. The load balancer will read it and make sure all your requests go back to the same backend server. Uh, the other feature of classic ELBs is it decouples the application environment and ensures high availability and fault tolerance. Uh, Limitations of classic ELBs: there's limited routing capabilities and fewer features compared to the modern load balancers. It was phased out since EC2 Classic has also become outdated. That's what deprecated means. So classic ELBs were used for legacy applications originally built on the EC2 Classic platform. That was pre-2013 AWS accounts. So yeah, that's the the first type of load balancer. And maybe what you need to take note is that instances are registered directly to the load balancer for this case. It's become outdated since the EC2 Classic platform has also become outdated. Okay, I think that's it. So we'll go to the second type of load balancer. This one is called an application load balancer. So AWS introduced version 2 load balancers to support modern architectures and VPC deployments. In this type of load balancer, you register targets within target groups, not directly. Like in Classic, you are connecting them directly. But here, you're registering targets within target groups. So let me just show you the image. So here, the classic load balancer is registered directly with the instances over here. But when we come here to application load balancers, they're registered to targets within a target group. So that's the difference. And a target group is a set of servers that do the same jobs and allow the load balancers to send each request to the right team. How it works, it operates at layer 7. Classic operated at layer 7 and layer 4. This one operates at layer 7. It is designed for web applications, microservices, and containerized apps. The features of application load balancers. Number one, it offers path-based routing. This means it directs traffic based on the URL path. Say the URL says it's to go to images, it will be directed to the images server. And it also offers host-based routing. It routes traffic based on domain names. So say the domain name is store.myapp.com. So this will be routed to the store servers. So these are the two routing options that it offers, path-based and host-based. The protocols it supports are HTTP, HTTPS, HTTP/2, and gRPC. It also offers dynamic port mapping. This means it allows multiple servers on the same instance via different ports. So normally, each service is assigned a fixed port number. For example, for HTTP 80, for HTTPS for 43. But with dynamic port mapping, each service or container can use a different port number automatically, whichever one is free. Another feature is application load balancers support dual stack and IPv6 only. When we say dual stack, it means it can support both IPv6 and IPv4 addresses, or you can configure it to only accept IPv6 only. It has enhanced metrics and access logs to monitor your load balancer and take action as needed. Deletion protection can be enabled to prevent your ELB from being accidentally deleted. Targeted health checks. It also offers targeted health checks for individual services. The use cases for application load balancers are they're ideal for modern web apps, microservices, and container environments. Yeah, so what you need to note about my goodness. Application load balancers is that you register targets within target groups and not instances directly. They are mainly designed for web applications, microservices, and containerized apps. Yes. Next, we go to network load balancers. So same configuration. This one is also registered to target groups, within target groups. And how it works, network load balancers are designed to handle tens of millions of requests per second while maintaining high throughput and low latency. So this one is meant for applications that handle tens of millions of requests and they require high throughput and low latency. So low latency, we said it's minimum delays, and high throughput, it's able to have traffic in and out with very much ease. It operates at layer 4. It handles TCP, UDP, and TLS traffic. The features, it can handle millions of requests per second. It supports static IP addresses per availability zones. It's ideal for volatile or sudden traffic spikes. It offers visibility into HTTP responses and health checks of hosts. It offers metric filtering based on zones or load balancers. The use case for network load balancers, they're built for high performance and low latency, and they're also built for applications needing extreme performance, static IPs, or non-HTTP protocols. Yeah, so things to note for network load balancers, they're meant for applications needing extreme performance, and they offer high throughput and low latency. And also note that they're ideal for volatile or sudden traffic spikes. The last load balancer we'll cover is the gateway load balancer. So the gateway load balancer is a specialized load balancer designed to deploy, scale, and manage your third-party virtual appliances like firewalls or intrusion detection systems. How it works? It works in wait. So it provides both gateway, that is, um, it works in layer 3 and layer 4 layers in the OSI model, and it provides both gateway and load balancing function. So it acts as a transparent detour for all types of IP traffic. So this one serves all IP traffic on its way from a source to destination. The gateway load balancer quietly redirects the traffic through security tools like a firewall or virus scanner without the source or destination noticing. The gateway load balancer the gateway load balancer transparently passes all layer 3 traffic through third-party virtual appliances. So this is what it means. Traffic is coming from the source, but before it gets to the destination, it passes through the gateway load balancer. This gateway load balancer will pass it to, oh wait, there's an explanation here. So traffic is coming from the source, and then the gateway load balancer forwards traffic to the healthy virtual appliance. Here, the appliance inspects the traffic. Wait, no, the appliance is here. So here you could have a firewall or an intrusion detection system, I guess, IDS. So here your traffic is coming from the source. It passes through this gateway load balancer. The gateway load balancer will take it to the third party virtual appliance, and this virtual appliance will check whether your traffic is healthy. It will inspect the traffic for viruses or threats. The appliance sends traffic to the GLB. So it sends it back to the GLB, and the GLB will send it to the destination. The source and destination never realize that the traffic was inspected. So this is what we're saying by the GLB quietly directs the traffic through security tools like firewalls or virus scanners without the source or destination noticing. Yeah. Use cases, security and deep inspection. They're used to insert and scale security, networking, or monitoring virtual applications into the network traffic flow without impacting performance or availability. Okay, up until there are any questions, are we good? Okay, I can do a short summary on the types of load balancers. So this one is the classic one. It's registered directly to load balancers, and it's a bit outdated because the classic platform is also outdated. The application load balancers, these ones are meant for web applications, microservices, and containerized apps. And here, the traffic is, um, it's the ELB is registered to the target groups within the targets within the target group. And then network load balancers, this one is for applications needing extreme performance, and they ensure high performance and low latency. And then gateway load balancers, we've said, oh, sorry. Gateway load balancers, these ones, they redirect traffic through security tools such as a firewall or virus scanner without the source or destination noticing. Okay, I'm going to assume there are no questions. So finally, we'll cover the elastic load balancer components. So this is the architecture. For the architecture is built upon three core components: the listener, rules, and target groups. So here we have the load balancer, and we're going to talk about listeners and rules and these target groups where the traffic is being redirected to. So we'll start with the listener. A listener is the process that defines how the load balancer accepts client connections. It checks for connection requests from clients. It specifies the protocol on which the load balancer will listen for traffic. An ELB must have at least one listener to receive traffic. Up to 50 listeners can be created on a load balancer. So when we talk about this listening that we're talking about, it simply means waiting to receive traffic. So when we say a listener listens on port 80, we mean it's waiting for someone to send a request to port 80. Once the request arrives, the listener decides where to send it based on the rules you set. So we'll talk about rules next. So in short, this listener, okay, let me give an example. Mm, okay, you know how in movies there's a person who doesn't understand what they're doing, but behind, like in the back end, there's a mastermind who knows exactly what needs to be done, but they can't be in that position. So, say this person who is clueless has an earpiece, and so the mastermind at the back end is able to listen in and say it's a business meeting. So the person in the back end is able to listen in and tell this clueless person exactly what to say, exactly what to do. So the listener, it's telling the load balancer what to do. The listener checks the traffic that has arrived, and then it specifies the protocol which or the port which the load balancer will listen for traffic. And then the load balancer will then decide where to send the traffic. So yeah. Once the request arrives, the listener decides where to send it based on the rules you set. So what are these rules? These rules tell the listener how to handle different types of incoming requests. These rules specify a target group, condition, and priority. The load balancer checks the rules in order and applies the first one that matches. Each rule has a condition and an action. E.g., if the URL path starts with stroke image, it sends traffic to image servers. So the rule is telling the listener how to handle the different types of incoming requests. The rules will specify the target group, a condition, and a priority. The load balancer will then check the rules in order of the priorities that you set above here, and then it will apply the first one that matches. The rule has a condition and an action. So say it's the URL path says this, so it's going to send the traffic to an image server. Every listener must have a default rule. This means if none of the other rules match the requests, the default rule decides where the request should go. So if none of the rules are matching the requests, where does this request go? So that's what the default rule does. So we've covered the listener. The listener will check on the rules and then now tell the ELB what to do. Now we'll cover the target groups. This is the last component of an ELB architecture. We've covered listeners, we've covered rules, and now we're at target groups. A target group is a collection of servers such as EC2 instances, containers, or IP addresses that actually handle the requests, e.g., web servers. Each target group runs a health check to make sure its servers are working properly. The load balancer forwards traffic to only the healthy targets in the group. So when you look at this example, let me just zoom in a bit. So when you look at this example, here the load balancer has received a request, and then checking on the rules, it has decided where everything will go. So if the request is on orders, it will be taken to the target group with order servers. If the request is on images, it will be taken to the server that with the targets being image servers. Registration, they're taken to registration servers. So these are the target groups. It contains servers that perform the same action, similar actions. So these ones are for registration, these ones are for images, and these ones are for orders. So traffic is routed based on the URL that the client requests. Okay, so let's go over the image once again, looking at the components. So the components of the ELB, we have the listener. The listener will look at the rules and then tell the application load balancer, the target group, that it's to redirect the requests. And then we've said that health checks are done within the target groups. And so each target is checked whether it's healthy. So we can see for this one, this first target group, all of them are okay. For this other one, all of them are okay. But for this one is not okay. Okay, so in conclusion, this story of the components, a listener receives a request. It checks the rules to decide where to send it. The request is forwarded to the right target group. The target group sends the request to only the healthy servers. Okay, so up until there, are we good? Okay, so here's a short summary of the types of load balancers. So we have the classic load balancer, the application load balancer, the network load balancer, and the gateway load balancer. The classic load balancer, it operates in layer 4 and layer 7 layers in the OSI model. The traffic types that it handles are HTTP, HTTPS, TCP, and SSL. The key features is that it is the basic load balancer. It was used for the outdated legacy EC2 Classic. Ideal use case, it was used for legacy apps. And then we have the application load balancer. This one operates in layer 7. The traffic that it supports are HTTP, HTTPS, and gRPC. It's suitable for, the key features are it offers smart routing. This one is where we were talking about it could be either routing based on the URL or, yeah, the URL, what? I've forgotten. Oops. And it also offers dynamic ports. So that's IPv4 and IPv6 can both be used. The ideal use case is web and microservices. And then we have the network load balancer. It operates in layer 4. The traffic that it supports, TCP, UDP, and TLS. Key features, high speed and static IP. The ideal use case is for high performance apps. And then we have the gateway load balancers. This operates in layer 3 and layer 4. It supports all IP traffic, and the key features are it's used for security and monitoring. Ideal use cases is when you need to redirect your traffic to firewalls or IDS so that you check for intrusions or threats. Okay, up until that, are we good before we do checkpoint questions? Any question? Why are people laughing? All right. Okay, we can do the checkpoint questions. Gideon, if there are any answers, please help me read in the chat. So the first question, which elastic load balancer will be appropriate for our website? Uh-huh. Guys, hey,
Guys, I'm looking at the chat.
Angela?
Musambi is saying, join.
Sorry. Just go ahead.
Okay, Musambi is saying classic load balancer.
mm-hmm.
Any other person?
Guys, a website runs on what layer? Yes, but Musembe classic load balancers are not used anymore.
Leonard is saying ELB, and Justin is saying ELB. Frank is saying application LB. I think they are correct.
Okay. So yeah, that is correct.
We also have Elfas saying application LB.
Boy, okay, just give me a moment. Okay, so yeah, the correct answer is the application load balancer. So we've said these ones are best suited for website and microservices. And the classic load balancer is the one that we're saying is outdated. So yeah, that's the correct answer, application load balancer. Second question, a developer must, okay, the answer is already revealed. Oops. Let me just hide again. Assume you didn't see. Okay, let me just leave it. A developer must select a load balancer to handle traffic to a new application. The application could potentially receive hundreds of thousands of requests per second. Often, the request will come in sudden bursts. So the question was, what would be the most suitable load balancer, and why would it be the most suitable? Who's going to answer? The answer is right there.
We have Justin saying NLB, network load balancer, because it handles lots of traffic. Felix is saying NLB, Elfas, network load balancer. Usambi, network load balancers are capable of handling millions of requests per second while maintaining ultra-low latencies. Network load balancer is also optimized to handle sudden volatile traffic patterns. And then Leonard Boma is saying network load balancer is optimized for ultra-low latency and can handle sudden volatile traffic patterns.
Okay, great. So you're all correct. The correct answer was network load balancer. Um, okay. Gideon, could you mute? Okay, so the network load balancer is suitable because it's able to handle millions of requests per second, and it's also able to handle sudden and volatile traffic patterns. The last question, which services support the implementation of scaling in AWS Cloud? A hint, there are three.
Daniel is saying Amazon Route 53, elastic load balancing, and Amazon EC2 autoscaling. Felix is saying ELB, and Fan is saying autoscaling. Then we have Habakkuk saying ELB. Alex is saying Amazon Aurora.
Okay, okay. The correct answers, okay, are Amazon Route 53, which we'll cover also in this class later on, and elastic load balancing, and Amazon EC2 autoscaling, which we'll also cover in the next class. All right, that's it from me. I hope you've all understood. I'll stop sharing now. Okay, thank you guys. So, for the next session, Gideon will be taking us through the other service that enables you to easily scale your resources. So, Karib, welcome, Gideon. You can take it away.
And Sandra, before Gideon comes on, I've not seen people appreciating Sandra for the good job she has done. Ebu makofi. Learn to appreciate people when they do good. Thank you, Elphas. I'm looking at your makofis. Belinda, why are you not clapping or laughing? Clap. Zikuja zikiwa rasha. Very nice. Sandra, that was a very good presentation and that was a very good introduction. And I really like the analogies that you have used. And just to encourage you and also the other presenters, know that when you go to an interview, a job interview, you will really need to use these analogies because someone will ask you to explain how load balancers work, explain the workings of a load balancer to a non-IT panel, and it's very common that you go for a job interview and then you have like only one or two people that have an IT background. The others are from HR, others are from other departments, but they are there and they would like you actually to explain these things in a way that they'll understand. So using these analogies, the same way you've seen Joy and myself use them in class, is very important. And I'm very pleased to see that you guys have also adopted that. So that was a very good job, Sandra. And if this is an indication of what your team is presenting, then we are up for a treat. So Sandra, back to you. Bring us the next speaker. Good job.
Thank you, Patrick. Okay, so for the next session, Gideon will be taking it up. Karibu sana, Gideon.
Asante, Sandra. Good morning, guys. I'll be taking us through AWS EC2 autoscaling. Before I do that, the initial plan was after Sandra's presentation, I'll go next, and then after that we do lab 174. So you guys can go ahead and open your lab, and as I do the presentation, mkomanza hiyo lab. So the objective in today's session, we will dive into the essentials of Amazon EC2 autoscaling and launch templates. And by the end of this session, you'll be able to describe what Amazon EC2 autoscaling is and how it works, configure and manage launch templates effectively, identify best practices for implementing autoscaling to ensure optimal performance and cost efficiency. I'm going to share my screen soon.
Okay.
Sijashare bado. I'm going to share. And then understand the flow of how autoscaling adjusts EC2 instances based on demand. And for an interactive approach, throughout the presentation, we will include interactive questions after each subtopic. For example, when I handle the first subtopic, we'll have some questions there. And then for the team support, I would like to welcome Fan, who will assist me with chat. If anyone has a question or comments during the session, Fan will help by reading them out, ensuring we stay engaged and interactive. So welcome guys, and kindly allow me to share my screen.
I hope you can, Gideon. Good. Good.
Yeah, I can. It's coming up. Can you see my screen?
Yes, we can.
Nice. So like I've said, we are going to tackle AWS EC2 autoscaling. I hope you can see my notes. Can you? Okay. So introduction, like I've said, I've given the objectives. So we will go direct to what autoscaling does. Autoscaling keeps your application running smoothly by automatically adding or removing EC2 instances according to demand. So it ensures high availability, cost optimization, and fault tolerance. And we defined the term fault tolerance before. Who can remind us what the meaning of term fault tolerance? You can type in the chat or unmute yourself and speak. Guys, kindly ndio tuwe mbio mbio we do the lab. Someone, you can you have the liberty to Google. Hakuna mtu, no one. Okay, let me proceed and give you the fault tolerance is the ability of a system to remain operational even if some of the components fail. So I hope we are together up to that point. So I have an analogy about autoscaling.
Gideon,
Yeah.
your voice keeps breaking, and I'm suggesting for you to repeat the question.
My question was the meaning of the term fault tolerance. Yeah, okay. Thank you, Juma Omonti John Paul. He's saying systems ability to keep working even when one or more components fail. And that is correct. So I think I can proceed. Think of an EC2 scaling like how supermarkets hire extra attendants during a December holidays. In this scenario, I'm using a Naivas supermarket as an example. Nowadays, Naivas runs with its usual number of cashiers, let's say 5. Holiday seasons are more customers flooding, so Naivas hires 10 more attendants to handle the crowd. After the holidays, traffic goes down, so Naivas reduces the number of attendants back to normal. So that's exactly how or what autoscaling does in AWS. When traffic to your app increases, AWS automatically adds more EC2 instances. When traffic drops or goes down, AWS terminates the extra instances to save cost. Guys, up to there, do you have any question? Because I'm going to ask you a question. Do you have any questions about what about autoscaling? Can you hear me clearly, Habakkuk? I hope you guys can hear me clearly.
Yes, we are able to hear you clearly, Gideon. Carry on.
Yeah, okay. Okay. Yes. So I'm asking, do you have any question about the what autoscaling does? If no questions, I have a question for you guys. So a company runs its web application on Amazon EC2 instances behind the application load balancer. The traffic to the application varies throughout the day. The company wants to automatically add or remove EC2 instances to match the demand and reduce costs. Which AWS feature should the company use? And you are going to read me the responses. Which AWS feature should the company use? Guys,
Angela
fine.
says Amazon EC2 autoscaling, same to Elfas, Habakkuk, Felix, and Naboth.
Nice. The correct.
Also, Gideon,
That is the correct answer.
your audio is kind of scratchy.
It is.
Yeah.
Gideon, are you using an earphone? What are you using?
No, I'm not using earphones.
You're using an earphone?
No, I'm not.
Just the normal Nini.
Yeah.
Sometimes it happens like that if you're using an earphone and then maybe the mouthpiece is scratching on something. And who has logged into two devices? Because I can hear myself.
I have one device on my side.
Okay. Just proceed. We'll just have to bear with you.
Okay. So we go to the next step, auto-scaling concepts. So we have capacity. We have scaling out and scaling in. We have instance objects. We also have a load template. Those are the auto-scaling concepts that we are going to cover here. Capacity. Capacity limits represent the minimum and maximum group size that you want for your auto-scaling group. The group's desired capacity represents the initial capacity of the auto-scaling group at the time of creation. So when we talk of capacity, we have when you are auto-scaling, we have the minimum number of instances, and then we have the desired capacity, then we have the maximum desired capacity, meaning for the maximum desired capacity, you'll define the maximum number of instances. In case the CPU utilization goes up, the maximum number of instances you can have, say 4 or 5. You're going to see this more in the lab that we're going to do. So the analogy, imagine you own a busy cafe near archives in Nairobi. You've noticed that on slow mornings, few customers come in. Around lunchtime, the cafe gets packed. By evening, it is calm again. So you decide to set up your capacity rules like shown below. I've talked about the minimum size, the desired capacity, and the maximum size. The description for the minimum size is the fewest workers that must always be there to keep operations running. A good example is you always keep one barista and one chef in the cafe, even during quiet hours. For the desired capacity, the usual number of workers you start the day with. So, you've defined the minimum, and then now you have the desired capacity, the usual number of workers or the usual number of instances in our case. You start with. You start each day with 2 baristas and 2 chefs because that usually meets normal demand. For the maximum size, the most workers you can accommodate, only the highest number you can accommodate of workers or instances in our case. You can bring in up to 4 baristas and 3 chefs when lunchtime clouds hit. These limits define your scaling boundaries. Autoscaling adjusts only within this range. So basically, in capacity, we are defining the range. The minimum we can have and the maximum we can have. Then we have the desired capacity. I hope we are clear up to that point. Now, on scaling up and scaling in, I believe Sandra tackled this. Scaling in is basically, scaling out is basically adding more EC2 instances, and scaling out is removing EC2 instances. We have the analogy there that is easy to understand. For instance, health checks, we have the definition here. Autoscaling automatically checks if your EC2 instances are healthy. If one fails due to network issues, software errors, or hardware faults, it terminates and replaces it. So when we talk of instance health checks, remember Sandra has also talked about this in her presentation. And she talked of ELB doing the health check of an EC2 instance. And when it realizes that an instance has some issues or is failing, it doesn't direct traffic to that instance. So basically, we have those levels of instance health checks, where we have the health check at the ELB level, and then we have the health check at the EC2 instance level. The analogy, think of a fleet of matatus managed by a circle. If one matatu breaks down on Thika Road, the circle immediately sends another one to keep passengers moving. Imagine town. Sorry, Frank. You are going to town, and somewhere on the way, the car broke down. So the circle sends another matatu to keep you moving. The same happens. So health checks are automatic health checks, and if an instance is failing, it is automatically terminated and replaced by another one. I hope we are good up to that point. Types of health checks, like I've said, we have EC2 status checks, ensures instance hardware and OS are okay. We have ELB or load balancer, elastic load balancer health checks, ensure instance can serve traffic properly. We have custom checks where you define your own health checks. The other autoscaling concept is launch template. I called it the master recipe. Before we proceed, we've covered a template before. We covered AMI. And who can remind us what an AMI is? You can chat, you can type in the chat, you can unmute yourself. AMI. And where do we use an AMI? Guys, come on. No, not Nini. I mean AMI, Amazon Machine Image. When you're going to read that for me.
Okay, Felix says it creates templates for new EC2 instances. And Salem says Amazon MI is an image used when creating EC2 instances.
Okay, thank you guys. Thank you. You're correct. So we said AMI is a pre-configured template, if you remember, that contains everything needed to launch an EC2 instance. It can include things like application server and applications. I remember yesterday Sal covered EBS, and he said that we need to attach a disk for the EBS in an EC2 instance. So it also contains storage volumes, permissions and metadata, configurations and setting, and more. So basically, like we said, it is a configured template. When we come to autoscaling, we have launch template. We already have a recipe to prepare a meal. So in such a way that when you want to prepare the same meal, you will not go back to the drawing board and try to come up with a new recipe. So basically, that what a launch template is. It defines how new instances are created. It's like a master blueprint, as it specifies instance configuration information. So a good analogy, think of the affordable housing project by the government. Before any flat in the project is built, the contractor must use a government-approved building plan. So this ensures every unit looks the same, and by that we mean uniform design. The plan includes all details, number of rooms, layout, wiring, plumbing, and all that. If an improved plan is introduced later, it can be approved and used for the next phase of construction. And so similarly, in AWS, when the autoscaling group needs to create a new EC2 instances, it uses a launch template, the approved plan for each new instances. So a launch template includes the following: an EMI ID, instance type, security groups, storage, IAM, role keeper, tags, and user data scripts. And we are going to see this in the lab that we are going to do after my presentation. So why does it matter? Ensures every EC2 instance is created exactly the same way, allows versioning, testing a new setup without deleting the old one, used by autoscaling group ASG to launch instances automatically. So we're going to see about all this, including the ASG we are talking about here. So do we have any questions? Guys, do you have any questions up to that point? If you have any question, you can type, you can unmute. I think we're good. Let's proceed. So I have a question for you guys. We're going to answer just one question. An autoscaling group in AWS EC2 has a minimum size of 2 instances, a desired capacity of 4, and a maximum size of 8. During peak traffic hours, the application automatically adds 2 more EC2 instances. Which statement best describes what is happening? Majibu niseme ni za Chapole Sigedheri. Guys, changamkeni, mnipe majibu. Fun, you can tell us what they are saying.
Sandra and Habakkuk are saying B. The autoscaling group is scaling out.
Mm-hmm. Anybody with a different idea? Anybody? So, they are correct. The scaling group is scaling out. I'm going to share this and you'll see more questions here. And in the interest of time, we're going to proceed to scaling types. So we have manual scaling, we have scheduled scaling, dynamic scaling, and predictive scaling. Manual scaling. You change the number of instances yourself. So the analogy, you personally decide to call in another chef in case you have a restaurant because the kitchen looks busy, no automation. So basically, in this session, we are covering auto scaling. So manual scaling means it's like you don't have any automation. We proceed to schedule scaling where you set specific times to scale in or out. So an analogy, lunch rush is always from 12 to 2 p.m. So you schedule extra chefs to come in just before noon. So the aspect of time is coming in here when you talk of scheduled scaling. Use cases, predictable traffic patterns, e.g. payroll, apps on Fridays. I think we are good up to that point. For dynamic scaling, the system automatically scales based on metrics such as CPU usage or request count via Amazon CloudWatch. A good analogy, your manager in the restaurant, say you have a restaurant, watches how busy the kitchen is and calls more chefs if orders pile up. When it comes down, it sends them home. Dynamic scaling is powered by CloudWatch metrics. So basically, the difference is for dynamic scaling, it is automatic in that you don't have to do anything. You've just configured the scaling in that when need other instances or when CPU utilization goes high, autoscaling takes control and other instances are added to handle the traffic. For predictive scaling uses machine learning to forecast when traffic will increase or decrease and then scales your EC2 instances ahead of time. So this can be confused with what we've learned about schedule scaling. Kindly remember that predictive scaling uses machine learning to forecast when traffic will increase or decrease. A good analogy, think of a Kenyan supermarket like Naivas or Quickmart in the city center. They know that every evening from 5 to 8 p.m., there's a big rush of customers. So instead of waiting for customers to crowd the store, they bring in extra cashiers before that time. I hope that is clear. Key points. These are like the features of predictive scaling. Learns daily and weekly usage patterns. E.g., we know Monday mornings are high, Sundays are low. Needs at least 1 day of historical data to start predicting. Forecast 48 hours ahead and updates every 24 hours. Best for apps with regular traffic patterns, e.g. news sites, e-commerce or payment systems with rush hours. Can be used together with dynamic scaling for maximum efficiency. So guys, take note of this. You unaweza pata a question in the exam asking which type of scaling uses historical data to start predicting. So in this case is an app with regular or repeating user patterns. And I have a question for you guys. You don't have a question for me. Do you have any question up to that point? Any question? I believe we are good.
There's a question.
Okay.
Felix
Felix
is
is asking. Go ahead.
Felix is asking, where does horizontal and vertical scaling fall?
Horizontal, I think vertical scaling is when you have one machine, one EC2 instance, and now instead of adding more instances, you just increase the CPU, the storage size. But for autoscaling, you increase the number of instances. You initially had one machine running or one server running, and then you go to scaling so that when the CPU utilization goes high, you have like two more or three more, depending with your minimum or maximum size. The maximum size you've set. Now you have let's say the maximum size is 5. In case the CPU utilization goes very high, and all the 5 instances are all running, it means for horizontal autoscaling, you just increase the number of instances. But for vertical, umeenda ukaongeza the CPU or the storage. I hope you are clear up to that point. Niambie kama nimekujibu. Nice. So I have a question for you guys. Allow me just 1 minute ni connect lab yangu kwa charge. 1 minute guys. Just a minute. So we proceed. Question. I think we can do question 1. And then when I send this, you can proceed and do the other question. So a startup wants its application to automatically add EC2 instances when CPU utilization exceeds 70% and terminate instances when it drops below 30%. Which type of scaling policy should they use? Majibu. Fan utanisomea?
Okay.
Guys tuchangamke. No responses. Guys, tumesoma sahi. The keyword is automatically. Guys, hakuna mtu anajibu? It's okay. The correct answer was B, but I'm actually sorry because we've not covered target tracking, but we're going to cover that in a few. So the correct answer is dynamic scaling with target tracking. So we proceed to auto-scaling policy. We'll cover what it is and yeah, auto-scaling policy. An auto-scaling policy defines how your auto-scaling group decides when and how much to scale, add or remove EC2 instances. Think of it like your rule book for hiring or sending home staff in a restaurant. When it gets busy or quiet, the rule book tells you what to do automatically. We have CloudWatch alarm-based policies. These are CloudWatch alarms to trigger scaling actions, and you're going to see this in the lab. If CPU utilization is higher than 70% for 2 minutes, add 2 instances. If CPU utilization is less than 30% for 2 minutes, remove an instance. There are two types, simple scaling and step scaling. For simple scaling, adds or removes a fixed number of instances, e.g. 1 plus 1 or minus 2. The keyword is fixed number of instances. An analogy like saying if the queue grows hire 2 more waiters every time. Step scaling, it adds or removes instances in steps based on how bad the traffic is. An analogy, if the restaurant is half full, hire 1 more waiter. If it is completely full, hire 3. So the bigger the load, the bigger the action. I hope you are good up to that point. And then we proceed to target tracking, and we've seen it in the question that we've just covered. So for target tracking scaling, this keeps a metric like CPU utilization close to a target value automatically. So note the keywords, guys. Keeps a metric close to a target value automatically. Example, target maintain average CPU at 50%. If CPU goes above 50%, it scales out. If below, it scales in. That is target tracking, and we have an analogy like a thermostat or a fridge regulator. If the temperature gets too high, the fridge cools down. Like Safaricom maintaining customer service agents so that wait time always stays around 2 minutes, not too long, not too short. And then it is the most common and recommended method because it is easy and efficient. We proceed to scheduled scaling. This lets you scale at specific times. You already know traffic will change, and we've talked about this before, so I will not belabor that very much. We also talked about predictive scaling, and we said it uses machine learning to forecast future demand. So I'm also not going to belabor that. We have one question here for you guys. If you don't have a question for me, a DevOps engineer at a Kenyan fintech startup wants their application to maintain an average CPU utilization of 50%. If CPU usage goes above 50%, more EC2 instances should automatically launch. If it drops below 50%, instances should terminate. The engineer does not want to manually monitor or adjust the servers. Which AWS autoscaling policy best fits this requirement? Nipeni majibu hapo, twende teketeke. Guys, I'm waiting for your responses. Alafu nimewapea what this nini does. So you can actually read this and give me the answer. Fan, you can tell me if anyone has responded. Mhm.
Elfas, Frank, Sandra, Angela, and Abbott, they all say B.
Yeah, they're correct. The correct answer is B. Yeah, nice. So we move on. Life cycle hooks. Guys, forgive me for the background noises. You'll have to bear with me. Life cycle hooks. These are pauses during instance launch or termination. So you can do setup or cleanup tasks. So when we say lifecycle hooks, the keyword is pauses. Like the CPU utilization, you did auto scaling and you had a maximum of 5 instances. And when CPU utilization was high, all the instances were utilized. But now the CPU utilization has gone down. So now you want to scale in. You just don't scale in. You need to pause in between so that the setup or clean, to make the process clean. A good analogy, think of a restaurant. When a new chef joins, you give them time to put on uniform and read recipes before cooking. When one leaves, you give them time to finish their last dish. You can imagine a chef was cooking and then the time to leave has come and he hasn't finished what he was cooking or preparing. So you can imagine how chaotic that can be. That's why we have life cycle hooks. If an instance was running and now the traffic has gone down, we need to terminate it in a way that we just don't terminate it at once. There are pauses before we actually terminate the instance. That's what we are talking about that's what we are referring to when we talk about lifecycle hooks. So use cases, running startup scripts, connecting to monitoring tools or graceful shutdown. We've talked of that. Send notifications to admins when scaling happens. Backup logs before termination. After that, we have termination policies. Who leaves first? In as much as we are terminating, like the traffic has gone down, AWS has a way of knowing who leaves, which instance are we going to terminate first. In the lab that we are going to do, we will see that though we will terminate manually, we will see this termination, like we will be terminating the initial or the first instance that we use to create other instances or to autoscale, though that we'll do manually. We will not use the termination policies. So instead of doing it manually, AWS has termination policies. They have a way of determining which instances is going to be terminated first. So think of a security company like a G4S reducing guards after a quiet night. They have a policy. Maybe remove the newest guard or the oldest one or the one closest to the end of shift. I hope that is clear. And then we have common termination policies. We have default, oldest instance, newest instance, oldest launch template, and closest to next billing hour. For the default one, it removes from the availability zone with the most instances. And then for the oldest instance, useful when upgrading to new instance types. We have the newest instance, helpful when testing a new template, but not keeping it. For the oldest launch template, remember you can have more than one launch template, removes instances from older configurations, and then for the closest to billing hour, saves cost by fully using paid time. I hope that is clear, guys. And then we can proceed to metrics and thrashing and steady state. So metrics, these are collected using Amazon CloudWatch, e.g. like CPU network. Use 1 minute intervals for faster reaction times. Turn on detailed monitoring for more accurate scaling. Then when we talk of steady state group, when your minimum, maximum, and desired capacity are equal, like they are all one, autoscaling maintains that single instance. If it fails, it is replaced. Use case. Maintain a single NAT instance per availability zone. I think we once talked about NAT gateway. If I remember, if my memory serves me, yeah, we talked about that. You can do more research on NAT yourselves. So analogy, your restaurant always has one chef on duty. If he leaves, another replaces him immediately. So avoid thrashing. Thrashing is equals to rapid scaling or scale out that wastes resources. And we talked about termination policies above there, not termination policies actually, lifecycle hooks above there. And we said those are processes when you are either scaling in or scaling out. How to avoid thrashing or rapid scaling in or out. You create an alarm to sustain period. Alarm sustain period. Wait for metric to stay high or low for a while before acting. And then we have a cooldown period. Pause further scaling for a few seconds after one change. Then we have instance warm-up period. Let new instances stabilize before evaluating metrics again. A good analogy, don't hire or fire chefs every 5 minutes. Let them settle before deciding again. And cooldown is equals to the stabilization time. So monitoring and best practices. Enable CloudWatch detailed monitoring, maybe 1-minute intervals. Enable autoscaling group metrics to view capacity forecast. Avoid burstable instances T3, T3, T2, T3 in scaling plans. Use multiple subnets, AZs for high availability. Always version your launch template for updates. Other instances stay untouched. So basically, guys, that is my presentation. And I don't know whether you have ample time to do a lab. So do you have any questions so far, guys? So then we can proceed and do the lab.
Thank you so much, Gideon, for that. That was a very good presentation. I want to suggest that we do the lab after a break, because that was quite a lot. We do the lab after the break. How many labs do we have from your session? From you guys, total? Do we have other labs for our 53 Cloudfront and name resolution?
Let me confirm.
Yeah.
We have.
So how many labs do you have in total?
Musembi, can you confirm how many?
It's just
How many?
2.
2.
Yeah.
Good.
Okay.
If it is two, then it's possible for us to take a break. When we come back, we can do 2 labs. No, we will do the lab that we are supposed to do right now, and then we get on with the presentation, and then we'll do that other lab maybe towards the end of your presentation before we go for lunch. But before we go, allow me just first of all, thank you so much, Gideon, and Sandra. Yes, and Sandra, the presenters for this morning. That was some very good job. Makofi kwao. Clap for them. Clap for them. Let me see you clapping. I can see your claps. Awesome. Good job. Thank you so much. So I want to ask you a very quick question through a poll. Please raise your hand if you have a Udemy account. If you have a Udemy account, kindly raise your hand. If you have a Udemy account, please raise your hand. I want to know how many people don't have, because I have something to give you that requires you to have a Udemy account. Please raise your hand and keep them raised. Trying to check how many people do we have here that have Udemy accounts. Cool. Okay, now you can unraise them. Then let me pose the second question. I've seen like 12 people. Just unraise them. Then I want to ask another question. And just raise if you, just answer me honestly. If you don't have a Udemy account, please raise your hand. If you don't have a Udemy account, please raise your hand. Please raise your hand. Please raise your hand. Udemy, raise your hand. Guys, I want your participation, because once I give the offer that I'm giving and then you miss it, don't blame me. Please let us just do what needs to be done very fast. If you don't have a Udemy account, please raise your hand. That is the simple instruction. Now, these numbers are not matching, because I saw we had like how many raised their hands that they had. And now this one that don't have 7. We only have 7 people who don't have a Udemy account. So wale wenye join a device, pole kwao. Pole kwao. This is the day that you are going to miss out on a very good offer. Now, we have discovered something good. Let me pause recording kwanza. Just give me a second. Where is that thing? Okay, cool. I found it. Guys, you can now unraise your hands. Thank you. You can raise your hands. Let's get to class. Cool. So Gideon, over to you.
Sandra, you can proceed and share your screen.
Okay. So I hope everyone has started their labs and we're ready to go so that we don't take much time. All right. So we're doing lab 174. Okay, just give me. Okay, Gideon, could you read for me the instructions?
Sure, yeah. So the lab is scaling, load balancing your architecture. Is someone on mute?
Okay,
Okay,
let me.
I don't think so. We can continue. So in this lab, you use ELB and Amazon EC2 Autoscaling to load balance and automatically scale your infrastructure. ELB automatically distributes incoming application traffic across multiple Amazon Elastic Compute Cloud instances. ELB provides the amount of load balancing capacity needed to route application traffic to help you achieve fault tolerance in your applications. Autoscaling helps you maintain application availability and gives you the ability to scale your Amazon EC2 capacity out or in automatically according to conditions that you define. You can use autoscaling to help ensure that you are running your desired number of EC2 instances. Autoscaling can also automatically increase the number of EC2 instances during spikes in demand to maintain performance and can decrease capacity during lulls to reduce costs. Autoscaling is well suited to applications that have stable demand patterns or have experienced hourly, daily, or weekly variability in usage. The following is the starting architecture, and you can see the architecture there. Initially, we have the public subnet A and another public subnet B in one VPC, and public subnet A is in availability zone A1, public subnet B is in availability zone 2. I think I can proceed to the final architecture where we have in the same VPC, we have a public subnet A and another public subnet B, and we also have private subnet A and private subnet B. But we have a lab instance in private subnet A with a security group, and we also have another lab instance in in private subnet B with security group, and in between you can see we have autoscaling group right there. Above there we have a security group also, application load balancing, whereby the load balancing is distributing traffic to the two instances that are shown in the architecture. I think we can proceed to the objectives now. After completing this lab, you should be able to do the following. Create an AMI. Guys, forgive me for the background noises, kindly. Create an AMI from an EC2 instance. Create a load balancer. Create launch template and an autoscaling group. Configure an autoscaling group to scale new instances within private subnets. Use Amazon CloudWatch alarms to monitor the performance of your infrastructure. So I think we can proceed to task 1 now.
Okay, okay. Okay, I can
Patrick, you are right.
proceed.
Sandra, Sandra,
Yes, yes.
Sandra, maybe before you proceed to task 1, let us go back to that architecture diagram. I want to point out something. Yes, good. So that architecture diagram, you see how it looks like, eh? It looks complicated to a beginner, but this is something that you guys will be able to do from as soon as you finish this program. But you will perfect these skills with practice, and you will also. This is what a solutions architect normally does, drawing this architecture diagram. See, you just heard the name architect. An architect, think of an architect that draws plans for a house. So this is like a plan for that particular deployment. And every deployment you'll be doing, should you, for example, get an opportunity to work with an APN, an Amazon Partner Network, where you're working with clients through the APN. So you will, one of the things that you will really do a lot of is draw this architecture diagram and also do costing for the resources that you are proposing to provision. Remember, we talked about costing and billing. So you'll also be doing a lot of that. And as I've just said, don't let this intimidate you. So one thing that I wanted to point out, I hope you guys are able to see the application load balancer, which has been covered in class. So anybody, the users that are coming, that are trying to access your instances, the instances are in a private subnet. And we say that anything in a private subnet cannot be accessed directly from the internet. So what happens there is that we have that traffic is being routed first through the load balancer, and now the load balancer will determine, based on the rules or the policies that you have defined, it will determine where to route traffic. Is it in private subnet A or private subnet B? And sometimes, yes, in the architecture, it might look like we only have 2 instances, but the number of instances you'll have, again, it will be defined by, for example, in this case, we are having an autoscaling group. So that autoscaling group will have defined, I believe it's Gideon who was teaching us just before we went for break, that in an autoscaling group, you can define your maximum, your minimum, and your desired number of instances at any given time. Now, for an e-commerce site, you know that during things like holidays, you need more. So you might find that maybe now the autoscaling group will now be forced, again, based on the rules that you defined and the traffic that you are getting, it will be forced now to spin more instances. And then when your traffic goes down, it will kill the instances and just have the minimum that is needed. So that's what I need. That's what I wanted to point out. But this is very, very good. Thank you. Let's proceed.
Thank you, Patrick. So we proceed to task 1, creating an AMI for autoscaling. Basically, guys, remember we are used to selecting the Amazon AMI, but now in this lab we are going to create one. And I remember Patrick at one point created another AMI using, I think, Ubuntu. So on the AWS Management Console, in the search bar, enter and choose EC2 to open the Amazon EC2 Management Console. Then they're saying in the left navigation pane, locate the instances section and choose instances. I hope you can see Web Server 1 instances listed. You now create an AMI based on this instance. Guys, if we go very fast, kindly let us know so that we can go together. So choose the Web Server 1 instance, which should appear in a running state. You can choose it. You just check it. Yeah, check it hapo kando. Yeah, that way. Actions huku juu before launching launch instance there. So from the actions drop down list, choose image and templates, and then create image, and then configure the following options. So click create image and then configure the following options. Enter web server AMI as the image name. And then for image description, which is optional, you can enter lab AMI for web server. Cool. And then from there you can choose create image. And they're saying the confirmation screen displays the AMI ID for your new AMI. You use this AMI when launching the Autoscaling group later in this lab. So we have the confirmation screen there. So we proceed to task 2, creating a load balancer. In this task, you create a load balancer that can balance traffic across multiple EC2 instances and availability zones. So in the left navigation pane, locate the load balancing section and choose load balancers. Guys, I hope you're going together up to that point. So where are we? In the load balancer types, no, okay. Choose create load balancer. And then in the load balancer types section, for application load balancer, choose create. Yeah, that one. And then on the create application load balancer page, in the basic configuration section, configure the following option. For the load balancer name, enter lab ELB. In the network mapping section, configure the following options. For VPC, choose lab VPC. And then for mappings, choose both availability zones listed. And for the first availability zone, choose public subnet 1. For the second availability zone, choose public subnet 2. And then they're saying these options configure the load balancer to operate across multiple availability zones. So in the security groups section, choose the X for the default security group to remove it. And then from the security groups drop-down list, choose web security group. They're saying the web security group has already been created for you, which permits HTTP access. In the listeners and routing section, choose the create target group link. Guys, I hope you can see and you're following through what Sandra is doing. And then on the new target group browser tab, in the basic configuration section, configure the following. For choose a target type, choose instances, which is already chosen for you by default. For target group, lab target group. Then at the bottom of the page, choose next. On the register targets page, choose create target group. Once the target group has been created successfully, choose the target group's browser. So there you're going to choose create target group.
Okay, here we're supposed to create next, and then when you come here, you review, and then
Yeah.
you create your target group.
Yes. And then you go back to the load balancers browser tab. In the listeners and routing section, choose refresh to the right of the forward to drop-down list for default action. So I hope guys are following. After refreshing, from the forward to drop-down list, choose lab target group. Yeah, that one. At the bottom page, choose create balancer. You should receive a message similar to the following: successfully created load balancer lab ELB, which we have. So for that one, we are good. To view the lab ELB load balancer that you created, choose view load balancer, of which by default in a Kuletea, you can view the lab ELB. Copy the DNS name of the load balancer. Use the copy option and paste the DNS name into a text editor. So guys, kindly mnaweza tupia thumbs up if you are together up to that point. That is if you are doing the lab with us. Nice. I can see we are together. So task 3, creating a launch template. In this task, you create a launch template for your autoscaling group. A launch template is a template that an autoscaling group uses to launch EC2 instances. When you create a launch template, you specify information for the instances such as the AMI, instance type, key pair, security group, and disks. So remember we covered this. So at the top of the AWS Management Console in the search bar, enter and choose EC2. In the left navigation pane, locate the Instances section and choose Launch Templates. And then on the Create Launch Template page, in the Launch Template Name and Description section, configure the following. On the Create Launch Template page, in the Launch Template Name and Description section, configure the following. Launch Template Name, which is required, enter Lab App Launch Template. For the template version description, enter a web server for the load test app. And then for autoscaling guidance, choose provide guidance to help me set up a template that I can use with EC2 autoscaling. I hope everyone is with us up to that point. In the application and OS images required section, choose the My AMIs tab. Notice that web server AMI is already chosen. Okay, scroll chini, if you scroll down, you see that web server AMI is already chosen for you. As you can see, in the instance type section, choose the instance type drop-down list and choose T3 micro. Nice. In the key pair, sorry, what happened?
I don't know. My mouse is okay. How do I go back? Oh, okay.
Just click. Okay.
Have seen. Okay,
Okay.
we're back.
Oh, okay. So after selecting T3 micro, and then in the key pair logging section, guys, chekeni tu tunaona. Confirm that key pair name drop-down list is set to don't include in launch template. Yeah, that one. And then there is they're saying here Amazon EC2 uses public key cryptography to encrypt and decrypt login information. To log into your instance, you must create a key pair, specify the name. This is what we've been doing when we were SSHing to our instances. So in the network settings section, choose the security groups drop-down list and choose web security group. Let's just scroll you. Choose create launch template. You should receive a message similar to the following. Successfully created lab app launch template, of which we have. Choose view launch templates. So to view, we are going to click this lab launch template. In the hapo kwa hiyo success message, you can just click it there. Task 4 is scroll. Task 4, creating an auto-scaling group. In this task, you use your launch template to create an auto-scaling group. Choose Lab App Launch Template, and then from the Actions drop-down list, choose Create Auto-Scaling Group.
Wait, what? I do what? Okay.
Choose Lab App Launch Template, and then from the Actions drop-down list, choose Create Auto-Scaling Group. Hiyo ya mwisho huko chini, the last one. Create auto-scaling group. And then on the choose launch template or configuration page, in the name section for auto-scaling group name, enter lab auto-scaling group. And then you're going to click next. Click.
Yeah.
Okay. On the choose instance launch options page, in the network section, configure the following. For the VPC drop-down list, choose lab VPC. From the availability zones and subnets drop-down list, choose private subnet 1 and private subnet 2. Then you click next. On the configure advanced options optional page, configure the following options. In the load balancing optional section, choose attach to an existing load balancer. Yeah, that one. And then in the attach to an existing load balancer section, configure the following options. Choose from your load balancer target groups. Choose from your okay, it is chosen for you. From the existing load balancer target groups drop down list, choose lab target group HTTP, that one. In the health checks optional section for health checks type, choose ELB.
Okay, for our
Remember,
case, it gives you the option to turn on. So just check it.
yeah. Remember we said that Sandra covered this about ELB health checks, whereby the elastic load balancer will be checking the health of our instances, and if one instance fails, the ELB is going to direct traffic to that particular instance. Then you can click next. I hope you have.
Yes.
On the configure group size and scaling policies option of page, configure the following options. In the group size option or section, enter the following values. For the desired capacity, we have 2. For the minimum capacity, we have 2. And maximum capacity, we have 4. So basically, guys, remember I covered this. We said that the desired capacity is what you are working with right now. The minimum is the minimum number of instances you can have, even when the traffic is not high. The maximum capacity is the highest number of instances you can have. So in the scaling policies option or section, configure the following options. Choose target tracking scaling policy. That one. For metric type, choose average CPU utilization. This changes tells autoscaling to maintain an average CPU utilization across all instances of 50%. Autoscaling automatically adds or removes capacity as required to keep the metric or close the specified target value. It adjusts to fluctuations in the metric due to fluctuating load pattern. And then click next. On the add notifications option of page, choose next. Click next. And then on the add tags option of page, choose add tag and configure the following options. For the key, enter name, and then for the value, enter lab instance. So, and then click next, choose create autoscaling group. The options are launch EC2 instances in private subnets across both availability zones. Your autoscaling group initially shows an instance count of 0, but new instances will be launched to reach the desired count of 2 instances. Remember we said the desired to be 2 and also the minimum. If you experience an error related to the T3 micro instance type not being available, then rerun this task by choosing the T2 micro instance type instead. So guys, you can give us a thumbs up if you are together up to that point.
Okay. So initially they're saying the instances were 0, and then when I've refreshed, it's set to the desired capacity. So now we have 2 instances.
Yeah,
Okay.
absolutely. Yeah. So thank you guys. So task 5, verifying that load balancing is working. In this task, you verify that load balancing is working correctly. In the left navigation pane, locate the Instances section and choose Instances. You should see 2 new instances named Lab Instance. Have you refreshed? These instances were launched by Autoscaling. If the instances or names are not displayed, wait 30 seconds and then choose refresh. You can see the instances, the 2 instances. So who can help us? Why do we have 2 instances? Remember we set the desired capacity to be 2. So initially, we are going to have two, and that's why we have two lab instances, as you can see. So first, you confirm that the new instances are passed their health check, which I believe they have. You can check. I think, is it there, Amma, down there?
I think it's here. Amma?
Oh, they are still initializing. Okay. Tutaangalia. In the left navigation pane, in the load balancing section, choose target groups. And then choose lab target group. In the registered targets section, two lab instance targets should be listed for this target group. You should see two instances. You can see the total targets are two. They're saying wait until the health status of both instances changes to healthy. To check for updates, choose refresh, and they are already healthy. A healthy status indicates that an instance has passed the load balancer's health check. The check means that the load balancer will send traffic to the instance. You can now access the instances launched in the Autoscaling group using the load balancer. So open a new web browser tab, paste the DNS name that you copied before and press enter. Can paste it there, then press enter. The load test application should appear in your browser, which means that the load balancer received the request, sent it to one of the EC2 instances, and then passed back the result. So we are good up to that point. You can give us a thumbs up if we are together. Thank you, Alphas. Thank you, Nicodemus, Ivy, Alex, Fan. Thank you, guys. So, task 6, testing autoscaling. You created an autoscaling group with a minimum of 2 instances and a maximum of 4 instances. Currently, 2 instances are running because the minimum size is 2 and the group is currently not under any load. You now increase the load to cause autoscaling to add additional instances. So return to the AWS Management Console, but keep the load test application tab open. You return to this tab soon. So in the AWS console, in the search bar, enter and choose CloudWatch. So in the left navigation pane, in the alarms section, choose all alarms. Yeah, that one. Yeah. Choose all alarms. 2 alarms are displayed. The autoscaling group automatically created these 2 alarms. These alarms automatically keep the average CPU load close to 50% while also staying within the limitation of having 2 to 4 instances. Choose the alarm that has alarm high in its name. This alarm should have a state of OK. So it is the first one, alarm high. If the alarm is not showing OK for the state, wait a minute and then choose refresh until the state changes. The OK state indicates that the alarm has not been initiated. It is the alarm for CPU utilization higher than 50, which adds instances when the average CPU utilization is high. The chart should show very low levels of CPU at the moment. Could you confirm that the chart is showing very low levels of CPU utilization at the moment? Can we be able to see that, Sandra?
Yeah, okay, just a minute. So when you were teaching us, you said the alarms, sorry, the alarms are the ones which trigger the scaling action. So here we have one alarm high and this one is alarm low. And then the option that we chose while we were selecting the scaling option, we selected the target scaling option, target tracking scaling option. So this one checks the metrics and then it now decides whether to scale or not. So here for the alarm high, it checks whether CPU utilization is greater than 50. If so, here it tells us if it's greater than 50, it's supposed to increase the instances. And then this one is alarm low. It checks whether CPU utilization is less than 45. And then it minimizes the resources that you have. So,
Yes.
okay, let me show the chart.
Thank you for that.
So
So you
yeah,
can,
here,
yeah, just proceed. You can see the CPU utilization at the moment is very, very low. I don't know whether you can see that blue there, where Sandra is placing a pointer. So that is it. I think we can proceed now. So return to the browser tab with the load test application. Next to the AWS logo, choose load test. This step causes the application to generate high loads. The browser page automatically refreshes so that all instances in the autoscaling group will generate loads. Do not close this tab. So you can see the load has gone to up to 72%. Return to the browser tab with the CloudWatch Management Console. In less than 5 minutes, the alarm low alarm status should change to OK, and the alarm high alarm status should change to in alarm. So to update the display, choose refresh every 60 seconds. Yeah, you can refresh. Where is the graph?
it's not yet made a change. It's not made the change yet. Okay, now it's increased.
Yeah, you can see the changes. And then they're saying the alarm low alarm status should change to OK, and the alarm high alarm status should change to in alarm.
Okay, it's not yet changed. It's still okay for alarm high and so I'm
Have you
supposed to wait. You have refreshed. Not yet.
Mm-hmm.
Okay.
It's still okay.
In the chart, it's showing that it's going past. Okay, let
But
me check.
now for the status, it is for the alarm low, it is still saying. I mean, for the
Okay,
alarm high,
it's changing. It's changing. Let's give
I
it
think.
time.
Okay.
Now they're both okay.
So initially, alarm high, alarm low status should be changed to okay, and then for the alarm high, alarm status should change to in alarm.
Let me refresh again. We see.
Yeah.
Not yet. Has
Could you
anyone
go?
checked?
Could you
Has
go back
anyone?
to the load test and then try to increase it again? You can click that load test button there.
What if? Okay.
That one. Click. Then go back to the console.
Not yet. Has
Maybe
anyone else's changed?
Well,
Maybe you could check.
for the CloudWatch alarm, it normally takes time for it to register. It is not something that happens immediately, because at the back end, there are other things that are happening. Say you connected it to an SNS topic, it sends you an email to tell you that one of your thresholds has been exceeded, So this will take some time. Click that alarm state. Oh, the alarm state, you set it to any Apoco filters. The alarm state is any, and alarm type is any. So that's okay. That's totally okay. So it should come. It will come eventually, because you see it changes from one set to another. So just keep refreshing.
Okay.
There is no way that we can proceed to the next step.
I think we
The next
can
step is
just,
terminating, eh?
Yeah, the next
yeah.
step is terminating.
Okay, so Ebu, just keep refreshing. But guys, it happens finally because you've just seen from the graph, it shows you that line has gone past the threshold that you had set.
Yeah.
It has gone past the threshold that you have set. So it will eventually come. But I was hoping if there was another step that we can do as we wait for that, that will really help because we are not doing very well on time.
I think we can just do this. We can proceed, and the thing that will confirm to us whether it has worked, we'll check the number of instances that we have.
Okay, Ebu, check the number of instances that we have at the moment. That's a good hack, by the way. Though ordinarily it's supposed to work from the alarms. It's the alarms that triggers the autoscaling thing to do its thing. How many? You see, we have already added.
Working.
See, we have added an instance.
Yeah.
Yeah.
Yeah. So it is working. It's working. So it's working.
Yeah.
So
Remember that. Yeah.
okay.
Endelea, Patrick.
No. Endelea. Niko sawa.
Thank you. So guys, it's working because initially we had the desired or the minimum number of instances. We set the number of instances to 2, and now you can see we have three lab instances, and the initial one, web server 1 instance. So they're saying wait until the alarm high alarm enters the in alarm. Imekataa. In the AWS Management Console, in the search bar, enter EC2. In the left navigation pane, locate the instances section and choose instances. More than 2 instances named lab instance should now be running. Autoscaling created the new instances. Penye tu tumesema what we've said. Lab instance, we can see we have three instances with the same name. Initially, we had 2, but now because of the traffic, autoscaling did its magic, and now we have 3. So the last bit, I think we can proceed to terminating, Sandra. Terminating the web server one instance. Remember I talked about termination policies, but now here we are going to terminate it manually. So choose web server 1 and ensure that it is the only instance selected. From the instance state drop-down menu, choose terminate instance. Terminate instance, and then choose terminate. And the instance is terminated successfully. And we are done. There is an optional challenge there. So if you have time, you can proceed and do that optional challenge on your own. So thank you guys. That's our presentation. Thank you for your time.
Makofi to that team. That was awesome. That was awesome. Yes, thank you for extending grace to them because this was actually a very long lab and a very important one. So I hope you guys have learned a thing or two. That was very, very good. Thank you. Thank you to Gideon. Thank you to you guys. Awesome. Okay, cool. So, cool. So what we are going to do, we will not do the other lab in class because of time. We'll not do the other lab in class. Sorry if there was someone that had prepared to do it from your group. We'll give them free marks for that because of time. So how many other presentations do we have, Sandra, to go? How many other presenters do we have?
We have two more, Musembi and Silas.
So what is Musembi presenting on?
On Route 53 and name resolution, and then Cloudfront will be covered also.
So who is covering Cloudfront? Still Musembi?
Musembi is the
let
one
me
covering
help.
Cloudfront.
Let me help Sandra.
Yes.
Okay.
So I Silas, I'm doing Route 53. Then Musembi is doing Cloudfront. And a very cloud. There is this other part that he's doing. Is it Musembi? Remind me.
Resolution.
Yeah.
It's a lab on Route 3 failover routing.
Oh, that activity, eh?
Yeah, but it has some issues, so I'm not going ahead to do it. I won't be doing it.
Okay, you leave that one. We'll try and check what the issue is after class. And then should we get a solution, I'll share with you guys. But what I wanted to request is that for the two presenters, I want you to share the time that we have. We have 30 minutes. We are going to extend our class to 12:30. So is it possible for the two of you to share that time?
Yes. Yeah, it's possible because it's very short.
Okay, cool. So let's proceed.
Okay, thank you. I'll take it on from here. Then Musembi will finalize it. Just a minute. I'm going to log in with another device because my laptop sound system is not that good. You will bear with me that.
Sure.
Recording in progress.
Can you hear me?
Yes, we can. We can hear you.
Let me just use my laptop so I can feel it's not working as I intended. I'll tackle Route 53 and very short and very clear. So if I can be allowed to share my screen, would be great.
You
Am I allowed?
you should be able to share your screen.
Okay, just a minute. What are you saying? Hello?
Yes, Silas.
What are you saying out there?
Yeah, we can see your presentation on what is Amazon Route 53.
Okay, thank you. Okay, so in short, let me just describe what is Amazon 53 because it's very short and very easy to grasp. Okay, Amazon 53 acts as a the same acts as a DNS service. Because the same way EC2 is a computer service acts as a computer service, the same way acts as DNS service. And if we all know what DNS does, it will be very easy for us to get this concept as soon as possible. So what does DNS do? DNS, we get to do this thing every day because we visit websites, we visit let's say Amazon.com. So a human being can't remember each IP address of every website that they visit.
Silas, your audio.
Yes.
Your audio keeps going far back.
Okay, how about now?
Now it's good. Maintain that.
Okay.
That is awesome.
Okay. So what I was saying is that a human being can't grasp every IP address that they meet with, every website with its IP address. But what we are good at is getting the names. So if you get Amazon.com, then the DNS will be able to convert Amazon.com to its IP address, and it will be much easier for us. So what are we saying? Amazon Route 3 is a highly available, scalable, and managed DNS service from AWS. Acts as an internet phone book, translating domain names, e.g. www.example.com into its IP address. Very well. I hope you're getting it. There are capabilities that it can do. There is domain registration. That's now the Amazon 53. You can register a domain, or you can should I say export or something like that? Because there is a way you can register a domain, say the Route 53, and there is a way you can bring your own domain name and register it into Amazon 53. It does also DNS resolution, which converts names into IP address. We talk about that. There is what does traffic management. Route user requests to a different AWS or on-premise resources. It also does health check. We talked about that earlier. I had the likes of Sandra doing something on that. And also there's the integration part, which works seamlessly with AWS services like EC2 and S3 and the rest. So why use Route 53? Guys, remind me of the time I should finish by 12:15 or even 12:12. So why do we use Route 53? One, it improves availability by routing traffic away from unhealthy endpoints, reduce latency by sending user to the nearest AWS region. We'll talk about that shortly on the policies that on the policies that Route 53 uses. It also enables disaster recovery by doing something that is called, you can see here, failover routing policy. And the last one is use a single service to register, host, and route. I said it earlier here, whereby you can register your domain, you can host already existing domain, and that's also the routing. So Route 53 and elastic load balancing. When you create a load balancer, AWS automatically gives it a default DNS name. For example, this one. You can use Route 53 now to assign your own friendly DNS, such as maybe www.myapp.com, and also route traffic to the load balancer. We have various routing policies. I'll only touch on the main ones because of the time. So we have the first one, which is simple routing policy. This is a default and most basic routing, where maybe you have one single source resource. It routes traffic to a single resource, such as EC2 instance, one load balancer or static website in S3. How it works? You create one record in Route 53 for your domain, example.com, and point it to one IP address. When user type your domain, the Route 53 returns its IP address. Once it returns its IP address, the user is able to connect to the S3. That's where it's connecting. There is this weighted routing policy. This policy allows you to distribute traffic among multiple resources based on assigned weights. A good example is For example, we have a resource center in Kenya, South Africa, and Morocco. Yeah, and we have our route 53 somewhere. So what does, maybe we say this one doesn't look where the user is, because we have the geographical part, where it looks the geography of where the person comes from, but this one doesn't look where the person comes from. But what we say is that among the requests that come in, let maybe 25% of the requests go to this resource center based in Kenya. 15% goes to where we said we have another one in South Africa. So we say 25 goes to Kenya, 25 requests goes to Kenya, 15 requests goes to South Africa, and the rest goes to Morocco. So you have distributed the request among the 3 stations that you have. So how it worked, that was maybe a short glimpse. If someone queries, the number of queries you should, if someone queries, that's sorry, that's a picture of it. If someone queries, we say that 15, 25, and the rest should get distributed in those regions as stated. Then another one is latency-based routing. Routers use the AWS region that provides the lowest latency. Lowest latency means fastest response time. For example, we have resource center A and B. So if from this picture, I don't know if you can see it clearly. Time is rushing. Oh, here. If here from this example, we see this. Let's say with two, with two, the latency rate is 53 milliseconds, and this other one is at 300 milliseconds. Of course, it will pick the 54 milliseconds because this is the lowest and fastest. Lowest is equals to fastest. That's what latency-based routing policy does. There is this other one, the failover. This basically means we have a backup. Having a backup plan, we have an active and a passive setup in a separate region. I can say this is it's all about redundancy, because once one let's say server goes down, we already have another one that's readily waiting to be activated. So like we are saying, used for high availability and disaster recovery, and creates an active passive setup where one resource is primary and the other one is a backup, which is passive. How it works, you configure health checks on the primary endpoint. If the primary fails, Route 53 automatically reroutes traffic to the second endpoint. That's very clear, by the way. Then we have this geological policy. This one we experience it like every day, because for example, one if your friend is in the States, let's say in the TX, and you're in Kenya and you open your YouTube, you will be given very different contents. That's depending now on the geographical area you are located in. It checks the user where the user is coming from. That's why you get the TikTokers, the content creators in Kenya. I'm almost done. What you see in Kenya is not what you're likely to see in US, because that's now hard coded in the Route 53 to show that where the user is located, the geographical region, the content from the geographical region where he's located or she is located, it's what she will see on the first page. We also have the proximity routing policy, where routes traffic based on the geographical location of the AWS resources. This geological routing was based on the user. And this one, proxy, it's based on the AWS resources, not the user. I hope you're getting that correct. So you can also shift traffic between resources by setting a bias. I don't know how to explain this, but hopefully you will. The last point, the last thing we tackle is the blue-green development. Let me help you read this, because 1 minute I'll be done. We're saying blue-green development uses identical production environment. Blue means current and green means new. To safely release updates and minimal downtime, Route 53 weighted routing gradually shifts the traffic from blue to green. Okay, simple terms, what we are saying. We have a development that's we want to shift some of, let's say, resources from point A to point B, from this server to this other one. So what happens? We don't shift everything at once. What we do is we start maybe by 10%, 20%, 50%, up to 100. Now that's what we are talking about here. That's what Route 53 does. As I wind up, where was I? If any issues are detected in the green environment, traffic can be quickly redirected back to blue. AWS tools like CloudWatch and CloudWatch logs monitor the health of green environment during the transition. Once the green environment proves stable, traffic is fully moved to it. The blue environment is then shut down, and after DNS records fully propagate. This approach reduces deployment risk and ensures continuous availability of this. This point. This one, very, very, very easy. Which routing policy? Wow. Which routing policy routes user to the closest region based on location? Because of time, I think this one, no, because I have read, I think this one is geolocation routing policy. You'll read it yourself. Which routing policy selects route based on the lowest latency? It's latency, it's self-description. What AWS infrastructure can Route 53 connect users to? We said S3, we say EC2, and ELB. Thank you so much, guys, for listening to me and for your time. Let me take this opportunity to welcome Musembi to do the rest of the work. Also, maybe you can add him 5 minutes for the time I consumed. Thank you so much.
Sure. Thank you, Silas.
Thank you, Silas. That was amazing. Patrick, can I share the screen?
Yes, you can. You have the permission.
Is it visible now?
Yes, it is.
Yeah, so in my part, I will be handling Amazon Cloudfront. And in this lesson, you will learn how to describe the Amazon Cloudfront content delivery network service. So if we ask ourselves, what is Cloudfront? We say that Cloudfront is a web service that speeds up the distribution of static. A minute, kindly, I move this. Cloudfront is a web service that speeds up the distribution of static and dynamic web content such as HTML, CSS, JavaScript, and image files to users. It delivers content through a worldwide network of data centers that are called edge locations. When a user requests content that you are serving with Cloudfront, the request is routed to the edge location that provides the lowest latency, that is time delay, so that the content is delivered with the best possible performance. If the content is already in the edge location with the lowest latency, Cloudfront delivers it immediately. If the content is not in that edge location, Cloudfront retrieves it from the origin that you've defined, such as an Amazon S3 bucket, a media package channel, or an HTTP server that you have identified as the source for the definitive version of your content. Now, basically what we are saying is that Cloudfront is used to deliver content fast, and it does that through the use of edge location, which are data centers that spread across different geographical areas. Now, to deliver content to end users with lower latency, Amazon Cloudfront uses a global network of more than 450 edge locations, 13 regional edge caches in more than 90 cities across 48 countries. And that is according to this map the one that we have been shown here, this map, which was updated by February 2023. Now, Cloudfront edge locations, which are also known as points of presence, make sure that popular content can be served quickly to viewers. It also has regional edge caches that bring more content closer to viewers, even when the content is not popular enough to stay at an edge location, to help improve performance for that content. Excuse me. Now, regional edge caches help with all types of content, particularly content that tends to become less popular over time. Examples include user-generated content such as videos, photos, artwork, e-commerce assets such as podcasts, product photos and videos, and news and event-related content that might suddenly find new popularity. The edge locations are connected to AWS regions through the AWS network, which is fully redundant, multiple 100 gigabytes Ethernet parallel fibers that circle the globe and link with the tens of thousands of networks for improved origin, fetches, and dynamic content acceleration. Now, I have some few analogies here that we can use to understand what Cloudfront is. When you think of Cloudfront, think, for example, a global logistic network with local warehouses. Instead of shipping every single package, which can be a file or a web page, from a central faraway location, our origin server, a delivery company keeps copies of the most popular items in numerous local distribution centers. The benefit here is that when you order something and you are far away, you as the customer, when you order a popular item, it is sent from the nearest warehouse, resulting in much faster delivery. Another example is that of a food chain preparation station. Cloudfront is like the preparation stations in a fast food restaurant. The kitchen prepares the core components of food, which is the data. Then the prep stations, which are edge locations, all the pre-assembled or common items, that is the cached content. So when you order a popular item, it can be quickly assembled from the preparation station without having to go back to the main kitchen, speeding up the service. Now, niwapatie ya mwisho. I think in our houses, everybody has tap water, majority of us. And normally you find that when you want to access that water, you don't go back to the source of the water so that you can fetch it. Yet the water is coming from a faraway reservoir, maybe a dam, a borehole, or a spring. Now, what happens is that water is collected from the reservoir and then brought near to you to the tanks so that when you need it, you can access it directly from the tap. Are we together? If we are together, you can give me a thumbs up in the chat. Cool. The next thing is the key features of Cloudfront. And when we say key features, we mean the main aspects of Cloudfront. The first key feature is security. The second one is availability. The third one is edge computing, real-time metrics and logging, continuous deployment, and cost effectiveness. Now, security. Cloudfront protects against network and application layer attacks. It delivers content, APIs, or applications over HTTPS using the latest transport layer security, that is version 1.3, to encrypt and secure communication between viewer clients and Cloudfront. It supports multiple methods of access control, and it is compliant with the major industry standards such as PCI DSS, IPA, and ISO IEC to help ensure secure delivery for sensitive data. Availability is the second feature. Cloudfront automatically serves content from a backup origin when the primary origin is unavailable by using its native origin failover capacity. Edge computing. Cloudfront offers programmable and secure edge CDN computing capabilities through Cloudfront functions and Lambda Edge. real-time metrics and logging. In this feature, Cloudfront is integrated with Amazon CloudWatch and automatically publishes 6 operational metrics per distribution, which are displayed in a set of graphs in the Cloudfront console. Continuous deployment. Cloudfront gives you the ability to deploy 2 separate but identical environments called a blue stroke green deployment. Joy, your bananas are working. Now, continuous deployment. Cloudfront gives you the ability.
Wanafunzi hawana akili. Ni watu wanakaa wako wamechanuka.
Who is that one banting?
Usikitu kwa wawili.
Lord,
Claude, you'll ban. You will ban.
Claude Tamaga Mtama. A minute, guys, I resize my screen. A minute. Okay. Continuous deployment. Cloudfront gives you the ability to deploy 2 separate but identical environments called a blue-green deployment and support integration with the ability to roll out releases gradually without any domain name system changes. Cost effectiveness. It offers personalized pricing options, including pay-as-you-go, the Cloudfront Security Savings Bundle, a custom pricing. With Cloudfront, there are no upfront payments or fixed platform fees, no long-term commitments, no premiums for dynamic content, and no requirements for professional service to get started. It offers free data transfer between AWS cloud services and Cloudfront. From here, we go to the use cases of Cloudfront. That is use cases, all kinds of businesses that require Cloudfront. Now, Cloudfront is a CDN service. A CDN, I mean content delivery network service, built for high performance, security, and developer convenience. It is ideal for use cases that require the following capabilities: the capability to deliver fast, secure websites. Companies can reach viewers across the globe in milliseconds, built-in data compression, edge compute capabilities, and field-level encryption. Accelerated dynamic content delivery and APIs. With Cloudfront, companies are able to optimize dynamic web content delivery with the purpose-built and feature-rich AWS global network infrastructure. You can stream live and on-demand video, whereby companies like video streaming services can start streams quickly, play them with consistency, and deliver high-quality video to any device with AWS media services and AWS elemental resources. Distribute patches and updates. Companies can also scale automatically to deliver software, game patches, and IoT over-the-air, that is OTA updates at scale with high transfer rates. Now, how Cloudfront delivers content to users. Just as I had given you the analogy, here we are going to discuss how Cloudfront makes sure that the content is delivered to the user. First, it improves content delivery by routing user requests through the AWS global backbone instead of the many networks that make up the public internet. Normally, when a user accesses a file, like the picture, that is example.com sunsetphoto.png, from a traditional server, their request travels across multiple networks before reaching the origin. With Cloudfront, each request is directed to the nearest AWS edge location, reducing latency and increasing the download speed. When a user requests an object, DNS sends the request to the optimal Cloudfront edge location. Cloudfront checks whether the object is already cached. If it is cached, it is returned immediately. If it is not, Cloudfront forwards the request to the origin, such as that is the S3 bucket or web server. The origin then sends the object back to the edge location, and Cloudfront begins delivering it to the user as soon as the first byte arrives, while also storing it in cache for future requests. Now, for cost estimation, Cloudfront is designed so that you don't have to pay any upfront fees or commit how much content you have. As with the other AWS services, you pay as you go and pay only for what you consume. When you begin an estimate of the cost of Cloudfront, you must consider three things. That is traffic, distribution, and data transfer. Mark that for cost estimation. Now, traffic distribution, data transfer and request pricing vary across geographical regions based on the location where your content is served from. Now, the request. You incur Cloudfront charges when Cloudfront responds to requests for your objects, which include the number and type of requests that were made and the geographic region where the requests were made. Data transfer out. You incur Cloudfront charges when users transfer data out to the internet and out to an origin or edge functions, which include delete, options, patch, post, and put requests. If you use AWS origins such as Amazon S3 or EC2 ELB load balancing, you pay only for storage and transfers out to the internet, not for any data transferred between these services and Cloudfront. Now, as we wind this one, we come to the key takeaways. Cloudfront is a CDN service that uses edge locations to deliver content securely in a highly available, scalable, and performant manner. It works with other AWS services to help you distribute content to users with low latency, high data transfer speeds, and no required minimal commitments. Cloudfront costs are calculated based on geographic region, number, type of request, and the amount of data that is transferred out. That is all for today. Thank you.
Awesome. So Sandra, does that mark the end of your presentation?
Yes, it does. We've covered everything now.
Ah, that's awesome. That was some very good presentations. Thank you to all guys from Team Air for that wonderful presentation. Guys, let's see some claps. Let's see some hand claps for this wonderful team. They've done a very good job, deserving of McCoffee. I'm trying to trace the question that you asked me about that activity. Musembi.
So I've been in touch with Joy, and I'm here to send the screenshot of what I was complaining about. So I think I hope other people will notice it.
The question in itself, can you trace your question? I just want the question as it was because I was working on it.
Okay, let me just tell you what the problem was.
I was working on it. There is something you said about path, eh?
Yeah, there is once you reach that step, that is number 18. I did not see anywhere to configure the path.
Now what happens, sorry for that. What happens is that, you remember I told you guys that these instructions were made long ago, and now AWS has changed how its console works. So what you do, once you have entered, I believe you are entering the IP address. Once you enter the IP address, kwa hiyo section, you will see that the IP address is called a /path, the default one that is there before you enter yours. So in order to set that path, there is no place that you will set the path. Instead, Apple kwa IP, where you copy the IP for Cafe instance 1, just put the IP then /cafe.
Okay.
/cafe. So that is one. And then when you proceed, I've also discovered that there is something that you'll also face as a challenge. Step number 19. Number 19. And guys, what I'm saying will be recorded. It will be in the records. So you guys, when you get stuck there, you can go back to that. So on step number 19, where you're supposed to be configuring the alarm, here you will have to navigate yourself out of where you are, out of Route 53. You will go and create you will go and create an alarm in CloudWatch. We've covered CloudWatch, so you'll go and create an alarm there. Then once you've created an alarm, within that same page, there is a place where they'll ask you if you want to create an SNS topic. So you will create an SNS topic in the same page. And then after you've created the SNS topic, the topic name has been provided for you. Then you can use your own email, recipient email address. Let me share my screen so that you guys, so that I make sense I make sense. We just go through this because it's important, and then you can go for lunch. Please confirm to me that you can see my Vocarium instructions. Somebody?
Yeah.
Yes, we can.
Okay. So going back, everything works until you reach point number 16. This is lab number. What lab number was this, Musembi? 170?
Oh, kidogo.
I think, yeah, it's 176. 176.
Yeah, 176.
176, JAWS activity Route 53 fail over routing. Yeah, Route 53 fail over routing. So I was telling you guys that when you come to this lab, everything will run okay until you reach this point number 16, where you are asked to create health check. So everything else, you'll do this, you'll do that, you'll do this. And then now when you copy this cafe instance IP address, and this cafe instance IP address is found here, when you come to AWS, you will be able, not AWS, sorry, what have I just clicked? When you come to details, to details, you go to this AWS here and show, then it will open up and you'll be able to see. You'll be able to see all the things that you will use. These ones, I hope you can see them. Cafe instance, primary website URL, secondary website URL, cafe instance 2, IP address. Musembi, can you see that?
Yeah.
Okay, cool, good. So that is what you'll be using in this step, because you'll be needed to go and copy that cafe instance IP address and input it. Now, where you are setting the path, you will not, there's no option for that. So instead, what you'll do, after you have copied your path, your cafe instance 1 IP address, add a slash and then add this cafe. Add cafe as your path. Okay, add cafe as your path. So the IP slash cafe. So cafe is like where you'll be directed to, or that is where the traffic is directed to. And that cafe path brings you to something like this. You see, it brings you to something like this or this. Remember, there are two cafes. There are two cafe instances. So this is for instance 1, and this is for the other instance. I hope that one makes sense. Then we go back to the instructions. Now, once you've done that, then you'll be able now to proceed. You can configure these ones without any problem. And then now when you get to point number 19, another problem will present. So here, you will not
Patrick,
get... Yes.
The lab does not show option for number 18 too.
For
you
number?
can click next. 18.
It does not show this.
Yeah.
It does not show option for number it does not show option for that next. So that's why I was telling you guys what to do when you are here. You see, when you're here after you have configured this, what are you seeing? Nishapita step. On my side, I've already passed that step. What are you seeing? Share your screen.
Nishafunga actually.
Oh, no worries. There is something that I did. No, you'll still remain in Route 53, yes. You'll remain in Route 53, but now, because this next option is not there, you will then go and create an alarm in CloudWatch. Please note that when you come to number 19, go to CloudWatch and create an alarm. Create an alarm. Let me see what, if I still have it open, just a second. I'm releasing you guys in the next 2 minutes. I'm so conscious of time. I don't want to put you here for long. I've been signed out. Yeah, my time ran out. Oh. Okay. No problem. No wahala. No problem. No problem. No problem. Okay, let's see. Aha. So yes. Yes.
You said we're adding a slash where?
After you have, are you in that step? Have you copied the IP address?
No, I'm just noting it down so
Oh,
that
yeah,
when
yeah,
I get.
yes. In point number 16, after you have copied the IP address, there is a space that will be provided for you to enter the endpoint. So you'll select specify endpoint by IP address, and then there is a box down there that allows you now to paste your IP address. Tuko sawa hadi hapo? Are we together?
Yes.
Then once you have done that, let me show you some. One sec. Is this one? Yeah. Okay, cool. Share. So once you have done that, once you have done that, you will add a slash like what you can see here. I don't know if you guys can see this. This is the IP that I nilieka, and then slash cafe. You see, slash cafe. Okay, slash cafe. Then you will still be in Route 53 because all these things that we are doing, we are configuring them in Route 53. Let me check this one for you. Just a second. Yes, you'll still be in Route 53. So when we are talking about you setting up your alarm will be for health check. Your alarm will be for health check. So you'll go to health check, to this health check tab, that tab there. And then now you will be able to configure everything from this point. But at some point you'll need to move. Like you see here, you create a health check. You create a health check. You give it the name of the health check. Why English, my friend? The name of the health check, Mandizi Menifikia, is provided here. Okay, so you'll put your health check name here. Like let me just assume that I'm doing this, although I've already done. Paste, good. Then we have been told to choose what to monitor as endpoint. So endpoint is here. Then we are choosing by IP address. And now this is what I meant. This is what I was talking about. Was that Sharon? I believe it was Sharon. So this is what I meant. Let me show you what you'll do there. So you'll come and pick your IP address. So I had copied it here. Copy that. And then come and paste it here. You see here. So before I copy, you can see we have an IP address slash path. You can see that? It is that slash path. So what we'll just do, we'll come and paste our IP and then add a slash, and then the cafe that we've been told to add as a path, we add it there. I hope that one makes sense. Have you seen that?
Yes.
Cool.
Yes.
Good. And then we check everything. If everything is okay, you can see here we are told that you expand the advanced configuration. I expand this advanced configuration here, and then you choose fast, request interval fast, and then you change this one to 2. Okay. Once you change that to 2, you will then drop down and yeah. So after you have set that to 2, you can see we are now supposed to mefikia pale, the place where Mzembe was saying we don't have this next. We don't have this next. So there's an alarm that we need to create. So creating this alarm, you will have to navigate yourself out of this place and go into CloudWatch and then create the alarm. Create the alarm. So one of the ways that you can do that is just go on and first of all, create your health check. Just create the health check without the alarm first. Let's see. How comes it has accepted to create another alarm of the same name? I already have an alarm that I had created. So from here, you will now be able to go to SNS, create an alarm, and then link it to this health check. Go create an alarm like here, for example, down here. You can see we have alarms. Wait, I'm trying to rush. Just a sec. So we have alarms here. You can create a CloudWatch alarm. This is the CloudWatch alarm that I'm talking about. Then clicking any of this will take you to a different tab. So click on that. What's this thing doing here? Click on that. Give it a second. Don't worry if I'm rushing, because I don't want to keep you guys here. I want you guys to go for lunch and then you come back active. Now, see everything here, all these steps you're supposed to do. All these steps you're supposed to set a number here. I think it's just a number that you need to set. Then when you click next, let's see if there's anything that we're supposed to do here. When you are creating an alarm, what were we told to do? So the steps to create an alarm has been given, but now at some point you also need to add an SNS topic. Oh, okay. Let me just use the default. That is 10,000. 10, 1, 2, 3, 10,000. We go to next. I hope it will not cause me problems. Then we go to actions. So actions, this is what will notify. For example, if you, okay, one of the actions that we are going to use is notification, because we want to be notified when the threshold that we have set is exceeded. When the threshold we have set is exceeded, maybe when that threshold is exceeded, it shows that our instance is unhealthy. You understand? It shows us that our instance is unhealthy. So we will pick notification and add a notification here and go with in alarm. You know what in alarm is? It has already been covered in class. So in alarm, we can either select an existing SNS topic or create a new topic. So we'll go with the create a new topic, and we've been given the name of our topic, have we? Let me see. We have been given the name of our SNS topic as public website health. So I copy that and paste it here, replace that. Okay, and then endpoint, you enter here an email. Okay, we already have one because I already created that. So I'll do that. And then I enter an email address. Let me enter a different one, patrick@lanleyafrica.com. Okay, then we say create a topic. When you create a topic, what happens immediately? You have supplied, let's say, an email like this. There is a notification that is sent to your email. There's a notification that is sent to your email. So let us just proceed first, and then I'll show you what I mean. And when you do that step, guys, pay attention. When you do that step, then that notification is sent. Okay, that one already exists. Let's change that one to 2. Next. There goes. Okay. And then now you can see, let us just create this alarm first. Yeah, so this is our alarm, and you can see here action enabled warning. So this warning, it shows you that when you click on this, let's just click on it and teremuka chini. What are we seeing? Give it a second. Actions. You see pending confirmation. So the pending confirmation bit, the confirmation is pending because I am yet to confirm something. So let me show you. This is the last thing that I'm showing you. I promise. So I am just sharing my email. So what happens is that there's a very high chance that that notification is sent to your spam. It will not come to your primary email email tab. So you go and look for it in spam. And these things we remember because you've done this over and over, and here it is. Oh, this thing, drop yourself. Here it is. You see AWS notification subscription. I hope you can see that. Cool. You can? One thumbs up is good enough confirmation. You can see this AWS notification subscription confirmation. Good, thank you, Felix. So, so this is this is not a spam. If you want such messages to be coming to your primary, you can mark the message as not spam. So the next time this is sent, it will now come to your primary. Then you just click here, confirm subscription. When you click confirm subscription, there it goes. And remember, when you're working in the normal environment and you're using SNS, this is SNS, simple notification service. When you're using SNS, you might have multiple people that need to be notified. Maybe you have DevOps engineers that will need to be notified. Maybe you have a developer that will need to be notified with the same alarm, so that they can be aware of what is happening in their account. So you can add multiple people that needs to be notified by their emails. And very, very finally, this is very finally, and I mean it. Let me just go back to this share. I want you to see here, we still have pending confirmation because I have not yet refreshed this this page. So if we refresh it, you'll see this will change. You'll see that will change. Give it a minute, just a minute. So we have created an alarm and we have attached an SNS topic to it. And remember, this is connected to what we were doing in Route 53. So when you come down here in actions, you'll see we don't have that warning anymore. So this has now been enabled. So should we exit that? It's the same thing that we saw them demonstrating the other time, that should that threshold be exceeded, you get an alert either to your email and to any other platform that you have enabled. I hope that one makes sense. That step makes sense. So after that step, all the other things flow as they should. Should you come across any problem, please get back to us and we will be able to guide you. Tuko sawa? Are we together? Good. Thank you, Gideon, for that confirmation. Awesome. So thank you so much again, Team Air, for that wonderful presentation. That was really, really good. Thank you so much for that. So in the afternoon, when we come back, we will be going on to the next topic. We'll be going on to the next topic. Let me see what the topic is. Let me see what the topic is. We had already talked about it. We were Team Air. Without us, you will die within minutes. Sawa tu. It's okay, it's okay, it's okay. So in the afternoon, we are going to do something very interesting. We are going to talk about serverless. And serverless is so important. So we'll be talking about serverless and containers. And to take us through it will be Chrome. So guys, let me allow you guys to go grab a bite. Otazamjua, and see you here at 2 on the dot. Sawa sawa. Bye for now and see you at 2. Chrome is loading. Okay. Okay. Let me stop sharing, stop recording.